All right, we've covered a bunch more material than is just in Chapter 1. Chapter 2 is on data types, but let's take a look at some data types. This is Interactive 14, and we created a table. It has varying 2, care varying 2, which is one of those data types. You can also put in varchar. In some other databases, it is not done that way. They have some variability on what the data types are and how they're specified. We have text data type. We have a UUID. And integer, the next one that I'm going to list here is numeric. Numeric is a packed decimal type that can store large numbers, I believe 130,000 digits in front of and behind the decimal point. But being packed decimal, it's suitable for calculations that are basically exact. You can't use a floating point for accurately calculating monetary types, but you can use numeric for doing that. So there are a slew of data types that are currently built in, and you can create your own types in Postgres. And I list some of those. Date is a really common one, and times. There is a timestamp, which is both a date and a time. It also has a time zone component to it, which is important. Realize also that time zones are not whole numbers. India is a half hour off. Bangladesh splits its difference between India and its next door neighbor, which makes it a quarter hour off. So timestamps do not happen in whole integers. There is a big integer, which for a lot of calculations is really good. There are decimals, floats, reals. We're going to have at least one of these things on using JSON data directly in the database. Postgres can do a wonderful job of indexing it. There's large floating points. There's bit types. Serial is a type that automatically increments inside the database. When you create a serial, it also creates a thing called a sequence, which has some advantages and some disadvantages, but do be aware that it's usually only a 4-byte integer, which means if you're dealing with big amounts of data, you can run out, and that is a huge annoyance. Intervals are sections of time. And you'll notice that I can say that an interval is plus or minus 178 million years. So you can do intervals that are very large. That's generally not useful for calendar dates, but it's useful for a lot of scientific computation if it's very large. Small intervals like an hour or a minute are more useful. Or you want to do calculations that are things like next month. It does have capabilities of calculating what constitutes months on the calendar. There's Boolean data. There's some geometric data types. And these are the base data types for geometric data, which are more suitable for scientific problems and things like integrated circuit board layout. But having the base capabilities for indexing and using polygons and lines and paths and circles is what PostGIS is built on top of. A complete geographic information system that you can add into your database that allows you to do things like street addresses. And there's a pretty substantial amount of use of Postgres. It's the only non-proprietary data system for this, and PostGIS is way better. I mean, a lot better than some of the other things out there for GIS data. Mongo's GIS data is laughably pathetic. Microsoft SQL Server, it's both expensive and not nearly as good. It doesn't have things like polygons with holes in them, which is kind of important. Oracle's is super expensive. I'm talking hundreds of thousands of dollars, and this is still a better solution to it, and it uses a better indexing system. So there's some good things like that. There's this pair of things called a TS vector and a TS query for text search. There are tools out there, like Google is one of them, but there's a more common tool called Elasticsearch, which is built on an open source piece of software called Lucene that does full text searching of documents. And basically this is allowing you to implement your own thing like a Google search. Google search has lots more capabilities, and you can actually, for many, many thousands of dollars, buy Google hardware to index your data using Google search. But short of spending a lot of money, if you just want to be able to search and do a decent job of searching words in a bunch of documents, like a blog or a content management system, this has a really nice search based on this pair of things that it can index with GIN indexes. And this makes for a good search solution. I mean, the University of Wyoming could search all of its pages. I think they're still using Google and Google hardware, but they could replace that with a Postgres database that would do just as good a job for what they're trying to do and provide you with a good search capability into their pages. There are types like INET and CIDR that are for internet addresses, both IPv4 and IPv6. And you can design your own data types so that you can make an extensible type system. Not just at the level of the database, but it's actually very straightforward in Postgres to actually build a truly custom type and extend the database itself. That's how things like GIN indexes and GIST indexes are implemented. So TS-Vector and TS-Query are actually add-ons to the database that these days have been integrated in, but that means that you're going to write an actual C extension to the database to implement this so that you can get custom indexing. But yes, it's trivial to add simple types, and if you need something really complex, you can do that. Now, we want to add a column to our database, to our table, that has updated and created, and here's the code for doing that after we've run the other stuff. So let's add that, and let's look at how you do triggers to get that updated to work correctly. The big magic here is when I do these things, first of all, I've added the columns to it, and now I can go in and I can, I'm actually going to cut and paste it. One of those things that we can do is, you notice that there was a default on the created timestamp just to the current time. That's easy. But if we want to get something that happens when the row is updated, what we can do is add a thing called a database trigger. And the trigger in Postgres is done with this name for the trigger on a particular, you tell it when. You can have triggers on update, delete, various different things. We'll have some examples of that eventually. But this one I'm interested in just on update on this table, and for every row that it does, it executes this procedure, this function called nameListUpdate. The function is right here, and it doesn't take any parameters, but it has some special parameters that are automatically given to it since it is a trigger, and those are referred to as new dot and old dot are in its context, its available globals. And whenever we have an update, and I'm doing this before the update occurs so that it'll actually be saved in the data for the row, it says take this updated field and set it to the current timestamp and then return the modified data. If you don't return the modified data, nothing will change. But with those lines, every time an update occurs on this table, I get to set the value of updated. You can have more than one trigger, more than one on before update. You can have after update. If you want to take something that's in the data and propagate it to a different table, that's one way to do it. You can do things like if you return new in a delete trigger, it prevents the delete from happening at all. As in, it tries to delete it, but it got back data, not an empty set when the trigger ran. So a before update on a delete, or a before delete trigger that returns new, stops the update from happening. So you can actually prevent data from being deleted. So let's create these two, create the trigger and the function. And other thing that I will point out is you notice that Postgres specifies what language you're using for the stored procedures. You can actually use other languages, including doing things like building your stored procedures in C code if you happen to need to. I have never actually done that, but I know it can be done. So here's our results of doing this, which is going to give us the table with these columns that track when things are actually done, when they're updated. And we could also do things like in a delete trigger, if you want to delete the data but you want to copy it to another table, you can actually take the data at that point and insert the data to a different table. So it can both be deleted and a copy can be saved, which means that on all of these things, they're tremendously useful for auditing certain kinds of data. And you can add this into somebody else's schema. Say you have some financial records and you'd really like to capture when stuff is being deleted or when it's being updated because somebody's doing something nefarious. You can sneak in some triggers into the database. They don't know that they're running, and suddenly you're capturing this information.